Hello, everyone. You are welcome once again to today's lesson. And today's lesson is going to be lesson 3 of binomial theorem. And in today's lesson, we are to bring the curtains down on this topic, binomial theorem. Okay, so without much ado, let's look at the solution to the worked example that we have there. So in lesson 2, we looked at how to expand binomial to any power using the binomial theorem. So we have the binomial theorem containing, what do you call it? The combination or involving the combination directly. Okay, and we said we can only use that one when, okay, the power of our binomial is a positive integer. Okay, so in today's lesson, we are going to make use of what we did in our previous lesson. That's a lesson 2. Then after that, okay, we'll use our expansion because lesson 2, we only dealt with the expansions. Now, in this question, you can see after your expansion, you are asked to use your expansion to find the values of what these two numbers that we have here. Okay, so quickly, let's go and have a look at what the solution. I'm not here because of what the A and B. I'm not here because, sorry, I'm not here because of the first part, the expansion. In fact, I'm here because of the A and B. So when we are looking at the expansion, you will help me expand or we'll do it together. So solution is what we write first. Okay, then the question number, obviously, question number 4. Okay, so as usual, we need to extract what we are giving. So this question indirectly is 3 in 1. Okay, the first part of the question, we are asked to expand 2 plus x all to the power 5. Okay, so we are supposed to expand everything, not to a particular, okay, term. So at this point, we are more than good to go. Okay, so we know here, because the exponent is positive, a positive integer, we can use the binomial theorem involving directly the combination symbol. So in this case, we know this will be equal to, okay, unfortunately, the first term is not 1 for us to have the special form of the combination 1. Okay, so we have to go the crude way, okay, not the special one. So in this case, fortunately, we know how to deal with that. So what do? We know this will give us, it will be n combination 0, but our n is what? 5. We are going to get 5 combination what? 0. Then we'll come and get our 2 to the power 5, then our x to the power 0. Is that clear?
Yes, please.
Okay, then plus, okay, what else? We are going to get 5 combination 1. Okay, then now our first term of the binomial, the powers will be decreasing. So it will be to the power 4. Then that of what? Our second term in the binomial, the power or the powers will be increasing. So let's continue. 5 combination 2. Okay, here we need all the terms. So we have to end at 5 combination 5. So then 2 exponent reduces by 1, so it will be 3. Then your x exponent will increase by 1, so it will give us what? 2. Okay, then plus, we go to what? 5 combination 3. Okay, our 2 exponent will reduce by 1, so squared. Okay, then your x exponent will increase by 1, so that will give us cube. Then plus, in any case, how many terms are we supposed to get from the expansion of this based on what we learned the last time?
6.
6 terms, 1 more than the exponent. Okay, so that will give us, so it means now 1, 2, 3, 4. We are left with 2 more terms to go. So that will give us what? 5 combination 4. Okay, then you get your 2 to the power 1. Okay, then your x, okay, to the power 4. Okay, then plus, I will come down. So plus the next one will be 5 combination 5. Okay, then your 2 to what power? 0. Then your x, okay, to the power 5. All correct, my professors?
Yes, please.
Okay, so the rest, the next term, okay, or the next step, 5 combination 0, any normal combination 0 is 1. Okay, so it means this will give us 2 to the power 5. Remember, okay, we are going to push in the powers and work on the combination, okay, values. So this will give us 1. Okay, this will give us 2 to the power 5 is what?
32.
Okay, so we are going to get 32. Okay, then this will give us what? 1. You can choose not to write even this one, I've told you. I'm writing it because maybe we are refreshing, okay, our level of understanding or our understanding. So let's go to 5 combination 1 will give us what? 5. Then 2 to the power 4 is what? 16. Okay, then we get x to the power 1, which is x. Okay, so then plus 5 combination 2. Hello, 5 combination 2 will give us
10.
10. Okay, then we get 2 cube will give us what? 8.
8.
Okay, then we get x squared. All correct.
Yes, please.
Then plus 5 combination 3. Also 10.
Yes, please.
Okay, so 10. Okay, then you get what? Okay, 4, which is 2 squared, then x cubed. We are pushing the powers in, then plus, okay, 5 combination 4 is what? It's 5. Okay, then, okay, you will get what? 2 to the power 1, which is 2, then times x to the power 4. But this time around, the 4 will come inside. Okay, then plus, okay, this will give us 5 combination 5 is 1.
1.
Okay, then 2 to the power 0 is also 1. Then x to the power 5. Is that clear?
Yes, please.
Okay, so the next step, we are going to remove the brackets, all the brackets. Okay, the brackets in each of the terms. And always, in this situation, when you remove the brackets, you land at your answer. After removal of the brackets, there wouldn't be any like terms for you to combine. So at this point, you know that immediately you are going to remove your final set of brackets. Okay, you can conclude at that point. Is my point well made?
Yes, please.
So you can imagine you don't write your conclusion there, then you are now going to write the whole of whatever that you are going to write there, that lengthy thing. Then after that, you need to come and conclude with that lengthy thing. So always think before you write. Or in case you realize that you were supposed to conclude there and okay, you didn't conclude, you can come and cancel the given and write there for here. You need to be smart. You get it?
Yes,
Especially
please.
when you are hard pressed for time. So at this point, I'll write therefore. But we always think before writing. So 2 plus x to the power 5. Okay, so I think my power is not appearing as a power. So my power is not powering. All right, so now let's look at what we have there. So that will give us what? 5. Then this will be equal to, so let's go. 32, right?
Yes, please.
Then plus 80.
80.
Okay, so 80x, then plus 80s squared. Okay, then plus 40s cubed. Okay, then plus
10x
to the power 4, then plus x to the power 5. All correct.
Yes.
Okay, so I should have said something in combination that I didn't say directly, but indirectly you should know. Okay, anytime you have this, let me quickly say it here. Today being our end, okay, I mean the last lesson. Anytime you have n combination R, okay, this will always be equal to n combination R minus 1. So it means, okay, 5 combination 3 will be equal to 5 combination 2. Is that okay?
Okay.
Did you say no?
No.
Okay, don't worry. Okay, so this is a relation. Okay, it's true. So sometimes this particular relation or fact that you have here, okay, you can see that this one is coming from the general point of view. I use specific to jump home my point. Can you see that? But these are specific values for n and r. Okay, so my point is anytime you have this is a valid statement. So sometimes you could be asked to prove that n combination r is equal to n, okay, combination r minus 1. Okay, unfortunately, we can't do that way. So you keep it, you know how to take this side, get its what do you call it, definition. deal with it, then come and take this side, deal with it, simplify, and you see that at a point you get the same result. But even it could be seen here, okay, 5 combination 2. Okay, is it not the same as 5 combination 3?
Yes, please.
So if my R, so here I'm picking my R to be the bigger one. If my R is 3, okay, it will be the same as, okay, when I subtract the 5 combination 3, it should be the same as 5 combination, and normal that I have to subtract 1 from this. So that will give me 2. So it means if I have, okay, 10 combination 9, this will be equal to 10 combination 8. Or I can also say that 10 combination 8 will be equal to 10 combination 7. You get the point? Okay, Prof. Aduma.
Mr. Hackman, please, so if I understand what you're saying, it means that 5 combination 2 should be equal to 5 combination 1.
5 combination 2 should be equal to what?
5 combination 1.
Okay, so it is 5 combination 2 the same as 5 combination 1.
No, please. So, like that's how I'm asking.
Okay, you are confused. So let me put it this way. Okay, so usually, okay, so this is what we are talking about. Okay, let me put it this way. Or should I hold on? At the end of the class, then we'll prove from here. Then I will say whatever that I want. Other than that, I will totally deviate from that.
Yes, please.
You get it? So you let's shelve this. Then I will draw your attention to what exactly I wanted you to know. Okay. I should have said it in the solution to the class test. Okay, I don't know why it escaped me. Okay, so at this point, we are done with the first part of the question. Now we are going to look at the second part of the question. This is where I want you to be very, very attentive. So A, what are we giving? 2.1 all to the power 5, is that not it? And always what will be asked to use your expansion to approximate or to evaluate. Okay, the powers must be the same before you can. Immediately the powers are not the same, you cannot. Okay, so what you have here, you can see that what you have here in your expansion depends on X. So you need to get a substitution for X to evaluate whatever that we have here. So you write this one to be a quantity plus another quantity. Okay, so that you can easily compare and pick the quantity that must take the place of X in this expansion. Should I come again on my point as well, May?
Please come again.
Okay. Okay, you can see that this expansion here depends on X. Is that not it?
Yes, please.
So if I know a particular X value, I will be able to get the actual expansion for whatever that I have here. So this a variable binomial expression and a variable binomial expansion. So it depends on a variable. So okay, let me quickly say that. So this, I know I can write this one as 2 plus 0.1. Is that clear? All to the power 5. Is that clear?
Yes, please.
Okay. And the reason why, okay, take note, I am starting with 2. I didn't start with anything, is that I don't want to be comparing oranges and apples, because what I expanded, okay, the first term is what is 2. So it means whatever that I'm going to do in terms of this number, you should have the same first term as what I have here. Okay, because someone can write this one as 1 plus 1.01. Am I right?
Yes, please.
Okay, but that might not work, and it will not work. Not that it might not, it will not work. Okay, because okay, you will be comparing oranges and apples. What you expanded, the first term is 2. Yours will be what? 1. So you have to be very careful how you break this one down into 2 terms, because you are dealing with binomial. So you should have 2 terms in your bracket. But here, how many terms do you have? 1. So you break it into 2. But when you are breaking it, I've given you that vital information. So it means here, comparing, I know that my X is equal to what?
0.1.
0.1. So I will go and write this will be equal to 32. So wherever I see X in that expansion, I put 0.1 there. So 80. And at this point, okay, I would need your calculator. So please, okay, the first hands, make sure you do the calculation for me for us to cover more. So 80 into 0.1 squared, then plus 40 into 0.1 cube. I hope you are following my professors.
Yes, please.
Then plus 10 into 0.1 to the power 4. You are supposed to use everything. So we need to make sure we cover everything. Okay, so I need to clear that. I said I will do that at the end of the, okay. So this can go. I wanted to drum home a particular point. This, okay. All right, so I guess by now, okay, you should be done with the terms, especially the one that you need to remove the bracket. So, but, oops, I am now going to, so I'm done, it's to the power 4, so it's left with the last one, which is what, 0.1 to the power 5. Okay, so this one obviously doesn't depend on x. So that will give us 32. I can't draw my conclusion here because I'm now going to remove the bracket in each of them. Then now sum. This one will give us a natural value. So my conclusion is not this. In any case, if you come and write therefore, and you realize that that's not your conclusion, you can still write another equal to. Is that clear?
Yes, please.
Okay, Prof. Samuela. Hey, I left one out. It seems I've left one out. I've left 4. It seems I've left 4 out. Okay, so then it means so I have to be equally careful. This wasn't intentional. I guess when I was cleaning, it distracted me. So 80, 80, 40, 10. So this one should have been 4. Okay, so I think that's the only problem. Is that not it?
Yes, sir.
So this should be 4 rather. Okay, so now let's go. This will give us, first of all, come and deal with the power. So I can deal with this one straight out, but when I come here, I have to deal with the powers first. If you can use your calculator to do everything, only that usually, let me advise, deal with the power so that for consistency's sake. So I'm going to get 80 into, okay, here the power is 1. So when it comes inside, it will still give you the same thing. Then plus, this one will give you 80 into what? 0.01.
0.01.
Okay, then plus 40 into
40 times
0.001.
0.001.
Okay, then plus 10 into 0.0001.
0.0001.
Okay, then plus, okay, 0.00001. Okay. All right. Okay, so now let's continue. This will be equal to, we are now going to remove, okay, the brackets there. So this will give us 32, then plus, hey, let's go. I'm waiting, my professors, are you there?
8.
8, okay, so you move the decimal.
8.
Okay, then plus 0.8. Then plus 0.04. Okay, then plus 0. Okay, so this one will give us 0.001. Am I right? Okay, then plus exactly what you have there, 0. How many 0? 4 zeros. So 1, 2, 3, 4. Okay, then 1. Okay, so we are now going to get our final answer. So sum everything. Okay, I'm going to squeeze the final answer here. I can't write here because of what I have here, so I'll rather write here. So I'm waiting. Sum everything. So at this point, you can use your calculator to do everything now. Come again. Come again. You said 40 what? Oh, your line is bad. Okay, another person should give me
40.8410.
Oh, it's 40.
40.8410.
Very good. That is exact. Is that not it?
No.
You approximated.
Yes.
Don't approximate yet because the maximum number of decimal places here will be 5. So you can write 5 dp. So give me the exact 5 dp.
Add 1.
Add 1 because 1 will be at the
Yeah,
end. So it will be 1. So don't approximate. Is that clear?
yes,
I
please.
told you the only point that you approximate will be where it is lengthy. 4 dp and 5 dp there. You get it. You can write it. So don't approximate. So at this point, this is what I want you to do. Okay, use your calculator to do 2.1 to the power 5 and call your answer for me. Do it directly. I want you to verify whether what you have here is right.
40.84101.
Come again.
40.84101.
The same thing, is that not it?
Yes, please.
Okay, so you've been able to get this, okay, not directly, but going through the binomial theorem. So there is nothing wrong. Oh, that's it for the A. So we are going to look at what? The B. Now, before that, any questions? Hello, my professors, any questions? Okay, we thank God you are fine. So we are going to look at that of the B. Okay, but before we come to that of the B, okay, quickly, there is another way to get your X. Okay, this is what, forgive me, I will advise you do. Okay, you know you are going to compare 2.1 and 2 plus X, am I right? So you can write 2 plus X should be equal to 2.1 and go and solve for X. So X will be equal to what? 2.1 minus 2 to give us 0.1. That's also another way to get the value of your X. Is that okay? But usually we want you to do this as a rough work. When you get your X, then you can come and write it that way. Is that clear? My professors, you are not responding. Are you all fine with this explanation as how to get your X? Okay, so I will take your silence to mean yes. So let's move on to the B. Okay, so visually, if you have issues, you will talk. So B, the same thing. What are we giving? Only that we've been giving 1.9, okay, to the power 5. Okay, so unlike the first one, the A, where we realize, so this one, I won't do it for all. Immediately we get the substitution for the X, I will ask you to go and continue. Okay, so in this case, okay, unlike this first one, the number here is greater than 2. So it means we can write this one as 2 plus a positive number. Is that not it? We are starting with 2 because we know that our first term must be 2. However, this number here is less than 2. So it means if I want to start with 2 plus another quantity, that quantity should give me a negative result, or it should be a negative quantity. Other than that, there is no way, okay, if it is positive, I will add and get a number, okay, which is what, less than what, or which is less than or even equal to 1.9. Is my point well made?
Yes, please.
Okay, great. Okay, so at this point, this is what we are going to do. So we know that this will be equal to, I'm going to write 2, but it will be 2 minus 0.1. Do you agree?
Yes, please.
Okay, so 2 minus 0.1, or somebody can write 2 plus negative 0.1 is the same thing. So it means here, your substitution for the X would be what? 0.1. Or better still, okay, we can equally do exactly what I just taught you. 2 plus X should be equal to what? 1.9. Do you get it? Okay, so in this case, X will be equal to what? 1.9 minus 2, which will give us what? Minus 0.1. So there again, I found, okay, the substitution for X, its actual value. Then you go and substitute that into your expansion. Then you give your, okay, approximation or your actual value in this case, because we're not asked to approximate. All correct.
Yes.
Okay, so at this point, you know, your substitution will be, please, because this time around is minus, we know in the expansion, we know this should be rather when you are substituting, your x should be negative 0.1. So it's going to give you 32, okay, plus, okay, the other one, what was there? Okay, I think it was 80. So 80. So it will be 80 into negative 0.1. Okay, then plus 80 into negative 0.1 squared. Okay, you continue. Okay, and I believe you should be able to. All correct. Can I end here and you will continue later?
Yes, please.
Okay, because the points I wanted. Did you say no?
Yes, please.
Okay. Who is that? Which of my professors is that?
Your favorite.
You give yourself accolades. All right, okay, so, but what is that, Prof. Adama, what's the problem here? You should be able to deal with it.
Oh, please, you may continue. Don't mind me.
Okay, don't worry. I know you are like that. Next time, make sure you take your drug before joining the class. I don't want this. Okay, Prof. Ama.
Mr. Akman,
Yes, my prof.
please could you move to the previous slide?
Okay, all right. So, but this one, take note, all the negative to even powers will give you a positive result. All the negative to the odd powers will give you negative result. So your plus and minus will be alternating. Okay, so she said I should go back.
So you didn't conclude for A and also B.
Yeah,
Which
but
is
I said it. Remember, I said it in my. I said it, though I didn't conclude, but I said it. Okay, so I said it even at this point, you can draw your conclusion. When you realize that is you still have work to do, then you can continue. I said it. So as normal circumstance, you are supposed to draw your conclusion. Okay. So you know that's for conclusion there. Even if I forget, you know you should do it. Okay, so you will do it. Okay, all right. So and again, if there's a rough word, don't forget to cancel it. Okay, strike out all your rough words. Okay, so another one. Okay, so let's see how we can deal with this. So maybe we'll do two more on the using your expansion to evaluate. Okay, so let's see. Let's read the question. Expand in ascending power. So underline that's very critical of x up to and including the term in SQ. Okay, and be careful. Let me add including. Okay, because I can add up to and excluding. Okay, so that means the s to the power 4 should come in. It should end at SQ. Okay, so now this is what we have. Solution questions are normal because we want you to normal your solution. Then what do we have given? Okay, first of all, we know 1 minus x to the power 11. We thank God. Our expansion here, the first term is 1. So our work is going to be easy in terms of the expansion, the first part of the question. Okay, and again, where the x is, the powers will be increasing. So it means, okay, I have to expand directly. Then again, hence, I must underline this. Then correct to 3 decimal, places of decimal with the same as decimal place. So you underline that as well. So here there is a required approximation, unlike the other one that we were not told to approximate. So we were compelled to leave our answer in its exact form. Okay, all right. So at this point, we know this will be equal to first part of the question. We need to expand this. We thank God. When the first term is 1, the special one, we know that the first term of the expansion will also be 1. Then plus, okay, n combination 1. So 11 combination 1. Then your x, but my x is minus x. Is that clear?
Yes, please.
Then plus 11 combination 2. Okay, then your minus x squared, it will be x squared, but your x is minus x. We cannot end because we have to end at to the power 4. So plus, we have 2 more terms to go. Okay, then we are going to get 11 combination 3. Okay, then you get what? Your minus x, okay, cube. Then plus 11 combination 4. Okay, then your minus x to the power 4. Okay, that's all. Is that okay? Is that what you will do?
No, please.
Okay, what is missing?
Ellipsis
Not just the ellipses.
plus ellipsis.
Very good. All right, don't forget the equal to is so plus some other terms that you are not interested in. Okay, because of the nature of the question. Please take note, this to the power 4. Okay, all right, so now we know we are going to get, okay, so let me see. Are we going to end at the answer straight away? No, we'll push the powers in, but someone who is smart, okay, can get the answer straight away. Let's do it systematically. So this will give us 1. 11 combination 1 is what? Any number combination 1 is the number itself. So 11, then times minus x. Okay, it is to the power 1. It will come inside. 11 combination 2. Hello, my professors. I'm waiting. 11 combination 2.
55.
Come again. 5, 5. What's this 5?
55.
5, 5. Okay, then if you push this one in, your power in, it will give you positive s squared. Then plus 11 combination 3.
330.
3,
130.
330. Okay, then x minus s cube will give you minus x cube if you put the powers. Yes, please. Come again. Your line is bad, my professor. Please come again. Oh, your line is bad. Who is that? Let me find out. Okay, Prof. Adama, are you the one?
No, please.
Okay, so then who is that? Prof. Ellen, are you the one? Your line is bad. Please disconnect and reconnect and come again. So please, is the value here wrong?
Yes, please.
Okay, so what is supposed to be there?
165.
165. So where is the 330? Is it for the next one? Okay, so come again, 165.
Yes, please.
Okay, all right, so 165, I'm going to write that. Okay, so transfer, I guess that was what the person, okay, was drawing my attention to. Them plus, okay, is it this one that will give you 3, 3?
Yes, please.
Okay, so the 330, then, okay, this will give us a positive x to the power 4. Okay, then plus your ellipsis. Okay, so in this case, this will be equal to, okay, you know, this issue could have drawn our conclusion here, and we are going to draw our conclusion here anyway. So let me draw my conclusion there, so that you also follow suit. So I'll have therefore, okay, 1 minus x to the power 11 will be equal to 1 minus 11x, okay, then plus 55x squared minus 165x cubed, okay, then plus what, 330, okay, x to the power 4, okay, plus your ellipsis. All correct?
Yes, please.
Okay, very good.
Yes.
So at this point, okay, we are done. Okay, all right, so then, but we are done with only the first one. This is in ascending powers up to and including the term in s to the power 4. That's okay. So let's come to the second part. The second part takes hence. So I can start with hence. Okay, so I'm going to write hence because my conclusion should take hence. Okay, what am I giving? 0.98 to the power 11. So let's check. The exponents are the same. This will be equal to, we know what we have here is less than what, 1. So it means if my expansion starts with what, 1. So I'm going to get, okay, 1 minus something. Is that not it? Because what I have here is 1, less than 1. If it was 1 point something, it would be 1 plus something. Is that clear?
Yes, please.
Okay, so let's go. That gives us 1, okay, minus, if you want to know, okay, as your rough work, 1 minus x, okay, should be equal to what? 0.98. So you are going to get x to be equal to what?
1 minus 0.98.
Which is what?
0.02.
Okay, 0.02. So 0.2 to the power 11. However, okay, what do you think will be the substitution for x? Will it be negative 0.02 or 0.02?
0.02.
In any case, it is clear here. Okay, because this is negative, they have the same sign. When you are substituting, you substitute only this. So at this point, I'm not going to continue. I think because of the approximation, okay, we'll do it up to a point, then I'll ask you to. So let's finish this maybe so that the next one I will just, okay, talk briefly. So I'm going to get into 0.02, okay, plus, okay, 55. If this happens to be a rough work, don't forget to cancel. 0.02 squared, okay, plus 1, oh, sorry, it's supposed to be minus. This is minus plus minus. So you have to be equally careful. Okay, so let's go. That gives us minus 165, okay, into 0.02 cube, then plus 330 into 0.02 to the power 4. Is that clear? Plus your ellipses if you like. So I guess you can continue, Abby.
Yes, please.
Okay, so this will be equal to, deal with the powers first. So we are going to get 11, 1 minus, okay, let's use everything. If you can use a calculator to do each of them, but don't use your calculator to do everything. At least if you won't deal with the powers, come and deal with the whole of this together. Okay, so let's go. The whole of this will give us, the whole of this will give us
0.22.
this 0.22, very good. Okay, then this one will give us, I'm waiting my prob because of the approximation, that's the more reason why. Okay.
0.022.
0.022. Okay. Then, which one? This one? Okay, so then minus 165 into 0.02 all cube. Feed your calculator with the same expression that we have here.
0.00132.
0.00132. Then plus one more.
0.0000528.
How many zeros? 4?
4.
Then
528.
528. Okay, if you are right, I'm also right. So plus ellipsis. Even in this case, because you are approximating, you can ignore the plus ellipsis. In any case, you are using only this to approximate. So you could have ignored the plus ellipsis. So now let's go with your final answer.
Mm-hmm.
0.78.
0.78.
Okay. And this is exact. Is it exact?
Mr. Please, are you talking about the whole thing?
Yeah, the whole of this. Now you can do it the whole of this using a calculator.
No, please, that's not 0.78.
So what were you doing?
I only did 1 minus 0.22.
Oh, you are doing everything. So do everything.
Sorry.
Okay, don't worry. I know you are like that. So, my professors, at least one of you, someone should be done. It shouldn't be only her. We are in the class together. We are in the business together.
Please, I had I had 0.8007328.
Everything exact.
Yes, please.
Okay, this can be, this we can write it. So now we are going to our approximation. You said, oh, before I move on, correct to 3 decimal places. This 3 decimal places? No. So 1, 2, 3. The next digit is hot, so I will add 1. So that will give me 0.80 and I indicate my approximation. Okay, 3 dp. Is that clear?
Please.
Okay, so that's all that is because of how you deal with this part of the question. That's the more reason why. Okay, I mean, this part of the solution. That's the more reason why. Okay, we went through that together. So with this one, I think, okay, the space was enough for you. The same question. I thought maybe there would be a spillover.
Mr. Hackman,
Yes, please. Should I go back?
you too.
Okay,
Thank you.
you're welcome.
Please, you could go back because
Okay, okay, so I can continue. Okay, so this one too, basically you should be able to do. This one is up to the term in SQ. Okay, then, okay, fortunately for us, our first term is what is 1. So we use a special combination and the power 2 is what is positive. So you can use this combination and use the special because it is 1. And this one too, you are going to get 1 plus 0.01. So your x in that expansion for you to find this will be 0.01. But again, to 3 places of decimals. So now I think this one should be, okay, yours. So you do it later. Okay, I'm not going to touch this. So at this point, okay, you have to go for your water break. Okay, by 11 o'clock, you should be back. Okay, so welcome back from the water break. Now with this one too, you should be able to do it. Okay, and I've told you, you can easily get your x by equating this one to this and solving for your x. Okay, so quickly, let's look at our next concept. All right, so this was the general rule or theorem, binomial theorem for that matter, that you are supposed to use when your exponent here is a positive integer. However, immediately your exponent here ceases to be a positive integer, you cannot use this. Okay, you cannot use this because in terms of combination, in terms of factorials, okay, you don't have negative numbers factorial. Okay, so assuming maybe you are given x plus y, let me write it here, x plus y, okay, all to the power -2. Okay, obviously, if you want to use the n, I mean, go our usual way, it will be -2 combination 0. Is that not it? Then the x to the power -2, that is possible. Then y to the power 0. However, the -2 combination 0 is not possible. So all of them, it will be -2 combination something, -2 combination something. And you know, your calculator, if you want to even use your basic appreciation of combination, this will give you -2, okay, factorial over, but you know, we don't have negative numbers. All correct.
Yes,
So it means, though the binomial theorem, okay, especially with the situation where you have the combination, okay, though that one makes the work easy or easier when the exponent is huge. So meaning it fills in where you have what your Pascal triangle not being able to cater for the situation, meaning being tedious to make use of the Pythagoras word, did I say Pythagoras, Pascal's word triangle. We use the combination to generate the coefficient. However, the combination equally has some shortfall, just as I just mentioned. If your exponent is negative or even a fraction, you cannot use combination. So in that case, does that mean we cannot expand, okay, binomials with negative exponents or fractional exponents? And the answer is no. We can expand, only that we can't use this to expand. So I'm going to walk you through how we can generate a formula, in that case a binomial theorem, okay, to use for that expansion. You know, the relation that we have here, the theorem that we have here, okay, we cannot use it because of factorial. I mean, use it for negative, or let me say it in general, and then, okay, positive exponents, okay, or power for your binomial because of the factorial in the combination. So we are going to take each of the combination coefficient that we have here, then write it in such a way that we will take the factorial, okay, of our n, okay, what we have here. By that, this is what I mean. We all know that n combination 0, okay, is equal to what? N factorial over n minus 0 factorial, then 0 factorial. Do you agree? Okay, which will give us what? N factorial over n, okay, factorial, then 0 factorial, which is 1. So in effect, this will give us 1. Do you agree? Okay, in the same way, if I have n combination 1, this will be equal to n factorial over n minus 1 factorial, then times 1 factorial, all correct?
Yes, please.
Which in effect will give us, let's go, n, you know that n factorial can contain n minus 1 factorial. We want to take care of the factorial with the n. Okay, so that will give us n into n minus 1 factorial all over, okay, n minus 1 factorial, then 1 factorial. I want to keep the 1 factorial. I will write it value here for the purposes of what I'm going to do. So please take note. You can see that the factorial is not affecting your n. So here it's affecting a positive number, so you are not worried. It is this number n that can be negative, or a fraction that we are worried about. We're going to take the factorial out of it. So this will cancel that, and we end up getting n over 1 factorial. Do you agree?
Yes, please.
Okay, in the same way, we can also say that n combination 2, okay, will be equal to n factorial over n minus 2 factorial, then times 2 factorial, all correct? Which will be equal to, we can write the n factorial to contain n minus 2 factorial. So that will give us n minus 1, n minus 2 factorial, all over what? Your n minus 2 factorial, okay, then 2 factorial. I will write a value there for the purposes of what I'm going to do. So this will cancel that. So I will get n into n minus 1 all over 2 factorial. Is that clear?
Yes.
So if you look at the pattern clearly, so it means this is what we are going to do. I can now comfortably say that my x plus y all to the power n, irrespective of my n, okay, whether it is positive integer, negative integer, what have you, okay, will be equal to n combination 0. But we know n combination 0 is what? 1. So I'm not going to write the 1 there. It's simply understood to be there. Then you get your x to the power n. As for the x, you can take the power, whether it's negative, what have you. So x to the power n, y to the power 0. Is that clear?
Yes, please.
Okay, then plus the next one will give us what? N combination 1. But n combination 1 is what? N, okay, over 1 factorial. Is that clear? So I'm going to get n, okay, over 1 factorial. Okay, then times what? X to the power n minus 1, then y to the power 1. All correct? All correct? Okay, so if you continue, the n combination 2, remember that gave us this. So that will give you n into n minus 1 all over what? 2 factorial. Then times what? Your x to the power n minus 2, then y squared. Okay, so the pattern, if you continue, we are going to get, you know, the next one, the denominator here will be 3 factorial. Can you see that?
Yes, yes.
Okay, however, the numerator will be n into n minus 1, then n minus 2. All correct?
Yes, yes.
Okay, the pattern, then you get s to the power n minus what? 3, then y cubed. Is that clear? Then plus your ellipsis. All correct.
Yes, please.
But take note, okay, immediately the exponent ceases to be a positive whole number, okay, or a positive integer, let me put it that way. You cannot find the number of terms in that expansion. Because assuming let's just do a little bit of reasoning. Assuming I have x, if I have x plus y to the power 6, if I expand, how many terms will I get?
7.
7. Assuming I have x plus y to the power -6, if I expand, how many terms will I get? And you want to say something, but obviously you can see that what you want to say doesn't make sense. I hope you cannot say -5 terms. You get the point.
Yes, please.
So anytime your exponent ceases to be a positive integer, it means the expansion will give you an infinite number of terms. So you cannot expand, okay, and give us all the terms. So usually in that situation, we will tell you to expand up to a particular point or up to a particular term. As for this one, we know we can get 7 terms. So it's a finite expansion. So you can expand, and even if the power is 1,000, you know you get 1,001. So if I give you the whole day, you can get us all the terms. Or if I give you time, you can give us all the 1,001 terms. But immediately I give you -6. Okay, you cannot. Because you are not even, in the first place, you are not able to determine the number of terms for you to know where you are supposed to end. So that indirectly will tell you that you have an infinite number of terms. And in the same way, if I have x plus y, okay, to the power maybe half. Okay, you know, if you go by our usual intuition, okay, whatever we knew, okay, we are supposed to add 1. So it means if you add 1, you are going to get 1.5 terms. It doesn't make sense to you.
No, please.
Okay, so once this comes in, it means your expansion will give you an infinite number of terms. So you cannot give us all the terms in the expansion. So please take note of that. Okay, so this will be, and this formula that you have here, okay, the one that I have quoted here, or we've quoted here, please take note. This one works for all. Whether your exponent is positive, a positive integer, or a non-positive integer, you get, okay, your expansion, okay, to be treated fairly by this, okay, formula or theorem that you have here. However, you can see that quoting this theorem is a little bit involving in terms of writing. Is that clear? So though this one works for positive as well, when the exponent of your binomial is positive, please don't quote this. I will advise you quote this one. And if the first term of your binomial was special, then you quote the special one of the combination. However, if your exponent is negative or a fraction, obviously you can't use this. So the only way out will be this one. So anytime you can use this, my point is you go for this one. But when you cannot use this, then you settle on this one. Is that clear? Okay, Prof. Ama.
Is that math? Please, could you explain what positive integer is? Is it negative?
No, you know your integers. What are your integers?
1, 2, 3, 0, -1, 2.
Okay, so you know, so if we talk of negative integers, if I say a non-positive integer, okay, it means I'm looking at negative integers.
Okay.
Okay, or indirectly, I can bring in fractions as well. So all other numbers apart from what? Positive integers. That's it.
Okay, sir.
Meaning non-positive what? Integers. Okay, all right. So now just like, okay, non-animals, okay, non-human beings. So obviously you know that you are looking at another category, the opposite, okay, category. Okay, outside the human category. Everything there would be non-human. Okay, so quickly, let's look at the next slide. Okay, I think I wanted to do something here, but because of time, I won't do it. I will use this one to explain. Okay, So when your first term is 1, okay, if your first term becomes 1, we are looking at the special situation for the expanded version of the combination. So usually I call this one the expanded version of the combination formula, the one that works for all. But I said, if the exponent is positive, don't use it because you write more. Okay, use this one. So this is the expanded version. The expanded version, if the first term is 1, you know that this will be 1 to the power n. So that will give you, okay, 1. Any 1 to any power is a number itself, and y to the power 0 will give you also 1. So it means your first term will be 1. Okay, then it means this will also give you 1 because it will be 1 to the power n minus 1, just as I explained in the special situation for the combination. And the y here will now be, in that case, we are looking at, I think, let me do it here, 1 plus x. So it means to the power n. In that case, okay, Professor, let me land. Okay, then I'll give you the opportunity. If I forget, please put up your hand again. All right, so we are going to get 1 plus x to the power n. So the first term, x is 1, y is what? Is x. So I'm going to get 1 to the power n, then x to the power 0. I know that this will end up giving me 1. Then plus, this will give me n, okay, combination 1. So I'm going to get 1 factorial. But usually, even this one, we don't write a 1 factorial, it is 1. So it will be n times this. We usually don't write this. It's a 2 factorial and what have you that you write. So I can ignore this. That's my point. Then you get x. Okay, by your x is 1. Let me substitute for n minus 1. Then your y is now x. So it means this becomes nx. Then plus the next one will be n into n minus 1 over 2 factorial. Then x was squared. Then plus n into n minus 1, n minus 2 s cubed over 3 factorial. And that is what, okay, was here. You can see. Are you okay with the special, okay, formula for special expansion for that of the expanded version using the combination? Expanded version of combination. Is that clear? Is my point well made?
Yes, sir.
And this one is very critical. Okay, whenever you have your first term is 1, okay, your expansion is valid. Okay, if your expansion will be valid, the x must be between -1 and 1. So usually we'll say that absolute value of x, okay, should be less than 1. Remember, we did this in series and sequence. Okay, so you should understand it. Which is the same as what? X is between -1 and 1. Okay, take note of that. All right. Okay, so we'll come to, let me quickly chip in. So it means if I have 1 plus 2x to any power, okay, my x will be valid when, I think, let me see whether the next question brings in that. Okay, yes, I think he said, and giving us any for x valid. Okay, so we'll look at that. This will be 2 in 1. Okay, so let's see how to apply what we just learned. Okay, especially the formulas or the theorems. Okay, the first example, for each of the following states the values of s for which the binomial expansion. Hello.
So you've forgotten about me.
Oh, I knew. Okay, that's why I asked you to prompt me. Professor.
Okay, so sir, I want to ask you. Let's start with the first formula, the one with the combination.
Yes.
So that one is used. I want to confirm something. That one is used when x is not, when n is a positive integer, right?
Perfect.
That's when it is used.
Yes.
And the second formula, when you expanded it, it is used when n is a negative integer, but x is not 1.
Yeah, but x is not 1. This is a general situation. Even if x is 1, you can use it. Only that if you substitute, you write more. Okay, because you are going to get 1 to the power. Remember, in this one, we did say, I gave you the special one for the situation where your first term is 1. And I didn't give it to you straight away. We generated that together. So you realize that we substituted 1 for this and 1. So now we are mature. So we should know that if it's 1 plus x, we should know the pattern that it will take. If you know it's general.
Yeah. Now let's go back to the first one. The first one, it is used when n is a positive integer, and even when x is 1, it can still be used.
It can still be used. Only that I advise is that if the x is 1, don't quote this. Go to the special situation for this.
So we should come to the second formula.
No, you've forgotten. Oh, my professor.
Or we should go to the...
Remember, you've used that here. You can see. This is it. We used it here. That's a special situation. Other than if you're going to use the y plus x, you are going to write 1 to the power something, 1 to the power, which you know in effect will give you 1 in all the terms, which will be a waste of time.
Yes, please.
You get it?
And the third, yes, please, I get it. And the third one, it is used when n is a negative integer and x is 1.
Wait, this one?
Yes, please.
No, this one, are you talking about this one? I guess there's the third one.
Yes, please, the third one, yes.
Okay.
When n is a negative integer and also a fraction, but x is 1.
Okay. Let me clear it.
But like
here.
the first number is 1.
Yeah, the first number is 1. That's what it.
Yeah.
But let me clear. Okay, maybe your statement. I said this can be used for all, whether you're irrespective of the value of your n, whether it's a positive integer and non-positive, you can use it. Only that it is best used. Okay, it is best used when the exponent here is not what? It's not a positive integer, because for positive integer, we know this can take care of it.
Yeah.
And looking at these two, which one is friendly to your eyes?
Looking at
these two.
The first one.
The first one. So where this one, okay, we can use this one, use it. But where you cannot use it, which is the non-positive integers, then you come and settle on this one. Okay, but this one can work for all. So in effect, this is universal in terms of the powers. But this one has a short for, you cannot use it for fractions, you cannot use it for what? Negative values of your n.
Yes, please.
Great, all right, okay. So now let's move on and see how best we can, deal with the next question. So this is a special situation of the expanded version of the combination. So this one, you can also use this one for a situation where it is positive. But I said, where it is positive, if you don't use the combination, you are going to write more, because this formula alone involves a lot of writing. Okay, because this that I have here, okay, I can write this as n combination 2. You get it? Which I can easily write it than writing this n combination 3. You see, that will save me time. The whole of this is n combination 3. Okay, all right, so let's go. If you get the point. Now let's see. For each of the following, state the value, okay, or values of x, okay, for which the binomial expansion in the given, okay, that is valid. So we are going to look at only the valid situations. Then it means I don't think I brought in where you can expand. Okay, so I think the expansion is here. Very good. Okay, so this is it. In terms of the validity of your x, that will make the expansion here, I mean, the value or values of x, that will make your expansion here valid. This is what we do. Please give me your maximum attention there. I was trying to explain it there, but I realized that, okay, I set questions on that. So A, what are we giving? 1 plus what? 2x all to the power -1. Okay, we know in general, if I have 1 plus x all to the power n, this will be valid when my x here, the quantity that I have here, my first term here should always be 1 before I can talk about the validity. So if my first term here is 1, the x here must be between -1 and 1 for it to be valid. Is that clear?
Yes.
So in the same way here, I'm going to write for validity. Okay, comma, my x now, my x is 2x. Do you agree? So my first term is 1. So it means my new x is 2x. And that must be between -1 and 1. Is that clear?
Yes, please.
Okay, so on that note, I know s must stand alone. So I have a compound inequality to solve for x. And I'm going to divide by a positive coefficient. So it means this implies that, okay, I'll write 2x is between -1 and 1 again. Divide this by 2. Divide this by 2. You remember solving compound inequalities? Okay, which will give us, therefore, my x must be between -1/2, then 1/2 for the expansion to be valid. Is that clear? Is my point well made, my professors?
Yes.
Or who wants me to come again? Today I've not asked this question. Okay, then B, what do we have? Okay, so B, look at what is going to happen. It's just basically, okay, the same thing. So you have given 1 minus 2 x to the power -2. Okay, for validity, we are not interested in the power. We are interested in the first term and what is being attached to the first term. So in actual fact, what we have here, the validity one comes with plus. So it means I'm going to write this one as, okay, as you mature, what I'm writing here will not be necessary. Plus -2, okay, to the power -2. Okay, so in this case, I'll write for validity. Let me come and continue here. So for validity, okay, I can basically write, this implies that instead of writing it. So for validity, whatever is standing being added to the x, okay, must be between -1 and 1. So this must be between, I could have written that here, okay, because this is too short for that. So please, when you are dealing with it, do it that way, -1 and 1. Okay, so here you can see that we are going to divide by negative, is that not? The coefficient of x is negative.
Yes.
So when you know that, okay, this implies when you are writing your next line for the inequality, you know, anytime you divide by a negative, you know you will be dividing by negative. So this sign must be reversed. This sign must also be reversed. Is that clear? Okay, then over -2 over -2. This is -1 over -2. All correct. So we are going to get 1 is greater than, okay, x, okay, and x is greater than -1 on 2, all correct. But I know this is the same as x is between -1 on 2, then 1. Afa. But if you end here, there are no issues. The statement here is the same as this. Only that usually we write it in such a way that the inequalities, okay, the sign will move towards the smaller number here. Okay, but here it is moving towards a smaller number, but it's to the side. Okay, Prof. Lynette.
I'm using the +1/2.
Oh, forgive me, 1/2. I ignored the 2, forgive me. I guess that's what, okay, this one wasn't intentional. Okay, it was due to old age, forgive me. Okay, so that is what we have there. So I guess my point is well made.
Mr. Appman, please, you've concluded twice.
No, I said it's either you conclude here or here. I said it.
Okay.
Okay, so you can see that this statement here is the same as this. So I can as well, only that, okay, if you look at this, because usually we don't see compound inequalities in this form, you see that your arrows will move towards the same direction in this direction, and not this. So this is not appealing to your eyes, but it's the same meaning here. So I decided to write it in the usual form, but it's the same thing. If you end here, it's the same meaning as this one.
Yes.
Okay, very good. All right, so with this one too, let me see. Okay, this one, you know, okay, always you have to make sure that your exponent is explicit. So for the C, okay, whatever you are giving, you don't see it to be a binomial to a power directly. Okay, so make sure you express it as such. So we can see that it's the same as 1 minus 2x all to the power -1. Do you agree? Please, do you agree? So it means it will basically be the same interval for this because we are going to use the same thing. What you have in bracket here to a certain power. I've told you your power is not very important. Okay, it is what you have here. First term is 1. So you should be able to know what must be here as well. Take note of that. Point well made. However, this one is half. So this one that you have here, let me quickly also run you through that. Oh, our time is up. Oh, we have 30 more minutes. Okay, so maybe the last, let's finish with this. We have to, we'll use one or two expansion, then that will be it. And the validity, please take note. Usually teachers don't teach, okay, but now of late, okay, questions are coming under it. So that's the more reason why. So if I have the other one, maybe if I had 1 plus, okay, just as I have here, if I have 1 plus 1 over 2 to the power x, you know, this will now give you all to the power minus 1 on 2. Do you agree? The D. So the exponent is explicit now. So this is x. So it means this one, the first term is 1. Okay, however, we know once the first term is 1, our x is now 1 over 2x. So you get 1 over 2x must be between -1 and 1. So here you multiply through by, so it means therefore you are going to get -2 is less than x is less than what? 2. So your x must be between -2 and 2 for the expansion to be valid. Is that clear?
Yes, please. Oh,
So just, okay, write this value, let it between -1 and 1 and solve for x if x is not solved for. So make sure that the coefficient of x is 1 in your conclusion. That's all. So if you need to multiply, multiply. If you need to divide, divide to make the x stand alone. But when you are dividing or multiplying, check whether you are going to divide or multiply by negative. If so, then the sign must be reversed. It's just like solving, okay, inequality, compound inequality for that matter. So thank you very much for this particular one. Now let's see. I think it's basically the same question. So let's go and look at what question. Let me see whether question 2 is the same. Oh, it's not the same. Forgive me. This time around, we are going to expand. Okay, then after that, find the validity. Okay, so 2 in 1. Expand each of the following in ascending powers of x. So ascending powers of x, ascending powers of x, up to and including the term in SQ. Okay, so SQ. Is that clear? That's the first. Then stating the values of S for which the expansion is valid. So expansion is valid. Okay, values of S for which the expansion is valid. So valid. Okay, so 2 in 1. Expansion, then the S that will make the expansion valid. So let's go for the first one, A. Okay, we are almost done. So question 2A. Okay, what are we giving? Okay, we are giving cube root of 1 plus x. Okay, but you know, okay, we can see that this is a binomial, but the exponent is not explicit because we have to make sure that our exponent is explicit. So I can say that this will be equal to, so once, let me come down, other than that, I can always say to be like, we're giving the whole of what I'm going to write. So come down, okay, and write your first equal to, so that your statement there will not be ambiguous. So this will be equal to, I know this is the same as 1 plus x all to the power 1 over 3. Do you agree?
yes, please.
Okay, very good. All right. So if we're able to do that of the fraction, okay, if the exponent is negative, okay, and it's a negative integer, you should be able to do it because that will even give you pretty, okay, values rather than a fraction. So can I use a combination directly to deal with this?
No, please.
No, why?
The power is a fraction.
Very good. It's not a positive integer. So it means here we are going to use, okay, the combination, the expanded combination. However, because the first term is 1, we'll use the special expanded combination. So here, this is what I'm going to write. Okay, so this will be equal to, you know, it is 1 plus x. It is in the same form of as your special form of the expansion, s plus 1 plus s to the power n. So that will be equal to 1, okay, plus, it will be nx, is that not it? Okay, let me put it so that you can appreciate it. So you know, usually the first one, I don't deal with it maturely. So as you mature, then we'll take that. So I can write but, okay, 1 plus x all to the power n. You know is equal to 1 plus nx, okay, plus n into n minus 1 over 2 factorial s squared, okay, plus okay, n into n minus 1, n minus 2 over 3 factorial, then s cubed. Okay, then plus your ellipses. All correct?
Yes.
Okay, so I can now say that therefore, whatever that I've been asked, I can't come and write equal to here because remember something has interfered. You know, right? So I need to come and write whatever that I needed to write here, which is equal to this, which is the cube root of. But I don't want to write implies and later go and perform my conclusion. So I'm playing smart here. So this will be equal to, now I'll come and compare here. 1 is 1, x is x, only that your n is 1 over 3. So that will give me 1 plus my n is 1 over 3. Then your x is still x. Is that clear?
Yes, please.
Then plus, okay, your n, which is 1 over 3, into n minus 1. So 1 over 3 minus 1. Okay, all over 2 factorial. I'm doing direct substitution. Then your x, which is still x squared. Then plus, okay, your, what do you call it? N, which is 1 over 3 into n minus 1. So 1 over 3 minus 1. My professors, I hope you are following. Then again,
Yes,
1 over 3 minus 2. So you can see that we are only doing direct substitution, all over 3 factorial. Okay, then your x, which is still x cubed, then plus your ellipses. Alpha, let me see. Yes, we're asked to expand up to the s cubed. If it is s to the power 4, then we'll continue. If it was s squared, would have ended here. Okay, and got the ellipses. So now I know this cannot be my final answer. No, therefore is here. So I'm going to write equal to. There's still work to be done. So I will get 1 plus 1 over 3x. So the first two terms, okay, intact. We are going to work on the other terms because you can see bracket there. So we are going to get plus 1 over 3 into 1 over 3 minus 1 will give us what?
negative 2 on 3.
Okay, all over 2 factorial, which is 2, is that clear? Then x squared, then plus, hey, let's go, 1 over 3 into, you've done that, minus 2 on 3. However, 1 over 3 minus 2 will give you what?
Negative 5 on 3.
Okay, then all over 3 factorial, which is what, 6. Then your x was cube, is that clear? Okay, so with a situation where the exponent is a fraction, okay, usually it's your algebra that must be on point. So this must be equal to, okay, Prof, plus your ellipses.
Yes,
I guess that was what you were drawing my attention to.
Yes, please.
Okay, very good. So I like the way you are always careful. Okay, all right, so now 1 plus, let's go, 1 over 3, okay, x. With this one, you can use your calculator. Use your calculator to do the whole of this. I'm waiting. Then we'll attach the s squared. In any case, you are going to get the 2 here will cancel the 2 in the numerator. So that will give us 1 over 9, minus 1 over 9. Am I right? Hello? Minus 1 over 9, s squared. Am I right? Then plus, let's go. This
Yes,
will be,
this is true.
okay, so this will give us, so with this one to, okay, we are going to get, use your calculator to do the whole of this, the coefficients. Or if you like, if you want to play it, okay, systematically, you can use your calculator to do the numerator here separately, so that your next one will be the value that your calculator will give you all over 2s squared, but that will be a waste of time. So use your calculator to do the whole of this. Then I'm waiting to add what? S cubed to it. Then plus the ellipses. Safa.
Yes, please.
Okay, so if you're able to do this, so this is the first part of the question. The second part, which is stating the value indirectly, we've done it. So with this one, what you have here is x. So this will be valid, okay, if x is between -1 and 1. So you will continue. Is that clear? So let me continue here. Okay, I think That is where I wanted to end. So let me end there. 1 will be okay. So this one is the same as, okay, this will give you 1 plus 2x all cube. Okay, but remember, you have square roots there. So you are going to get, okay, 1 plus 2x all cube. Okay, the whole of that to the power half, so times half. So it means, in effect, you are going to get 1 plus 2x all to the power 3 on 2. Is that clear? So your n will be 3 on 2. However, this time around, your x will be 2x. But your first term is still 1. So when you are substituting, this will be 2x. Okay, this will be 3 on 2, 3 on 2, 3 on 2, then 2x squared. Put that in brackets. Is that clear? Your 2x in brackets. Once you have you, then you move on. Is my point well made, my professors?
Yes, please.
Okay, great. Any questions at this point? Okay, Prof. Amma.
So, Mr. Akman, when we are done with the one we are talking about right now, then we write hence the value of f for which is valid is -1 less
Okay.
than 2x.
Okay, no problem. Do you see hence in the question?
No.
Okay, so you can avoid using hence and use therefore for the second part of the question.
Okay.
Okay, so after this, you've drawn your conclusion for the first part. So the second part will be, okay, therefore, this one is direct. X must be between -1 and 1. We don't solve.
Okay.
Right, because it was 2x. Even if you write therefore here, you continue. Okay, meaning after concluding, you realize that you still have more work to do. So you can keep the therefore there and continue, but make sure nothing comes under the therefore.
Yes, please.
All right. I guess my point is well made. Okay, so what this is supposed to be our, what do you call it? I mean, the last session, and like I told you, the last part of what the binomial theory. Unfortunately, time will not allow us to deal with this. But let me quickly walk you through one of these, okay, ones. Okay, so with this one, you don't have to expand this. Keep this calm and expand this. But when you are expanding, be mindful of where you are supposed to end. So if you are expanding this, you don't need all the terms, but you need expansion up to, okay, the term in SQ. So when you get to that term, then you bring plus ellipses, then you close the bracket, then later come and multiply each of the terms. Is my point well made?
Yes, please.
Okay. Then when you are multiplying, anytime you come and multiply the first term here and all the terms in this expansion where you expanded up to, when you multiply any term that is greater than, that has the power of x greater than 3, you don't write it. It will later be part of what? The ellipses. Is my point well made? So the expansion, we should see only a constant term, a linear term, a quadratic term, and a cubic term. Any other term apart from these terms, okay, must be part of your ellipses. Okay, as simple as that. So please, okay, take notes. Okay, maybe when I'm preparing you towards WASI, I will bring in the more technical questions. Okay, then we'll deal with that. Okay, so on this note, okay, thank you very much. We've done well, at least, okay, we've handled one more topic. Okay, so it means in general, we did 3 major, and I repeat, 3 major topics, broad topics for that matter. Okay, even with the binomial theory, we are not done. In certain situations, you could be asked to find particular terms. So we didn't do that. Okay, in our next meeting or next vacation classes, okay, if God, okay, permits, we'll look at questions of that sort too. But at least the basic information that you need to appreciate the concept of binomial theory, okay, you have it now. So any teacher that walks you through, okay, binomial theory, you should be able to appreciate it, because I know, okay, by the grace of God, I have given you a solid foundation. All right, so on this note, okay, so we are going to bring the class, okay, to an end. So God bless us all.